Good to go? All right. So here we are completing the square. We're going to take this general form and we're going to convert it into vertex form. All right. Let's look at that picture again of the x squared and the x's in the box. So this is x squared. That means this length is x. This length is x. Now look at your middle term and take half. What is half of 6x?
3x.
3x. So this is going to be a 3x and this is going to be a 3x. So if this is x and this whole area in here is 3x, so this side has to be 3. Would you agree with that? Mm-hmm. And same up here, this is going to be a 3. That means this whole thing is going to be a perfect square.
Yeah.
So what number has to go in here?
9.
A 9. All right, well, I don't have a 9, but I'm going to put in a 9. So this is how we're going to write it. We're going to have y equals x squared plus 6x plus 9. And I'm going to put that part in parentheses, right? I'm going to put what I originally had there, which was negative 3.
And then plus 3?
Well, no, not plus 3.
Minus
I have to
9.
look what did I add here? I added a 9. It's not legal to add 9. It's legal to add 0.
Yeah.
So I have to do a minus 9. Okay? Because a positive 9 and a negative 9 would make a 0, and it's always legal to add 0.
Okay. And then you would factor out the part in parentheses.
Actually, I should already know what it is because of what I did here, right? We're going to write it as a perfect square. Y equals x plus 3, quantity square, minus 12. So what's my vertex?
Wouldn't it be minus 3 comma 12? Minus 12?
So this would be your h, and that would be your k. Making sense? Good to go? All right, we'll do one more example. And our next one is the y equals x squared minus 10x plus 7. So we'll draw our little picture down here. If you've ever done algebra tiles, it's just a concrete way of looking at it. If you haven't, the pictures, I think, still help give you the idea of what you're doing here. X length, x length. What is going to be the half of a negative 10x?
Well, minus 5 and 5.
No, minus 5 and minus 5.
A minus 5x and a minus 5x. So just divide it by 2.
Oh.
Okay? Now, it's kind of funny to think of this length as being negative 5, but we're just going to think of it that way, okay?
Okay.
So that's where it kind of breaks down. Okay? It's not fully realistic, but it's close. All right? Now, what is negative 5 times negative 5?
25.
So that's going to be what goes down here. All right? Now, is this a 25?
No.
No, but we know how to handle that, right? Okay, so y equals x squared minus 10x plus 25. We're going to plop that in parentheses. We're going to put what we started with originally, which was the plus 7. I added 25. That's not legal.
So minus 25.
Minus 25. Okay, so we're going to rewrite it as a perfect square. X minus 5, quantity squared, minus
18.
18 looks good to me. Yeah, what's my vertex on this puppy going to be?
It'd be 5 minus 18.
5 and negative 18. Perfect. Okay? Can you see how that makes it easy to be able to graph?
Yeah.
Okay. It's also kind of an interesting thing if you remember when we were trying to graph it using the h equals negative b over 2a, right? Well, we're taking b, right? The opposite of that would be
Negative b.
which would be a positive 10. Divide that puppy by 2, you get a 5. And a here is 1. So you can kind of see where the negative b equals 2a to come up with the h part.
I'm sure this is going to get interesting once you get a coefficient with the x squared.
What you have to do is you have to factor that out in order to have the x squared in parentheses, and then you complete the square on what's inside. Okay? But that's basically what you're doing.
Okay.
Okay? But you can do it if it's fractions or whatever, or negatives. It's no biggie. It just takes a little bit of practice. Okay? How are we doing on that one?
Good.
Good.
Yeah? We got some time still?
No, it's a blinking low battery.
Okay. Let's go ahead and turn that off,
Okay.
and I'll stop.